Everyone understood this problem? Any issues you have it in this one? As I said here, for this one, we have two simplified expression because the mean term 0 could be combined with the mean term 1. So that what is like the expression for this two group of mean terms, w bar, x bar, y bar. Similarly, what we have, the mean term 0 could be combined with the mean term 8. So that what is the expression for this one, we can have x bar, y bar and z bar. So that what we, that's the reason we have two simplified expression, a non-unique simplified expressions, right? We'll go to the next one. Simplify the Boolean function, right? Simplify the Boolean function, which is given as w is equal function of input variables w, x, y, z. And for this mean terms, what we have 1, 3, 7, 11, 15, it is 1, right? The mean terms 1. And the don't care conditions are what? For the mean terms 0, 2, and 5 here. Everyone note down this one. Since there are four variables, draw the four variable K-map. Draw this one. Now just looking at the this equation, we know for which mean terms it is 1, for which mean term it is D. Right? It is given as D here. It means that this don't care here what we have it. The don't care condition terms are given here. Now accordingly write this one. For which mean terms it is 1 and for which mean terms it is D. And write it in those particular squares there. Now once you write it, now see whether those don't care conditions will help us in creating larger group of main terms. Identify the prime implicants and essential prime implicants here. Yeah, Sahana NB has written. Okay, that's good. Now if you see how we can group this one, we can see here the main terms 1, 5, 3 and 7. We can group this way, right? Now also you can see here 3, 7, 15 and 11, right? These four mean terms we can group, right? So that we can have a group of four mean terms here, right? And what about this one? Can we group this way also? Can we group this way? The mean term 0, 1, 3 and 2 here. We can have this as group. This is second group what we can have, and also we can have this as a third group here. Now, is this group needed here now? Now you need to see which are essential group of mean terms here now, right? Which are required terms for the simplified expression. Someone has written, yeah, Mega has written, right? Okay, I can see the students trying in parallel with me. I really appreciate the students who work with me, right? Because that's what I say. That trying is more important than being correct, right? So that you can see from this one thing what you can understand here is the mean terms 0 and 2 are don't care conditions here, right? If I make a group of this four here, if I group of 4 here, what will happen there? You can see that the mean terms 1 and 3 are already included in the groups of what? 1, 5, 3 and 7 mean terms group. Now what you can see, if you include this term, this is becomes more of a redundant terms, right? It is not adding any value addition to the simplified expression here. And here this 0 and 2 are don't care conditions there, right? So that what you can do, if we see from this one, Kavya has returned, that's good. It means that this term what we have is not needed. It is not needed. Why it is not needed? Because this mean terms what we have 1 and 3 are included in the group of mean terms here 1, 5, 3 and 7 here. Any of 0 and 2 are don't care conditions there. Right? And again we have this one. So that what we have is which group of mean terms is we need to include this one and this one. We don't have to include this group. Understand here because the 1 and 3 are already included in the group of 5 and 7, right? And since we know that the mean terms 0 and 2 are don't care conditions, right? So that what are the expression we have it now? Everyone understand this one? This scenario what we have it here, right? Because this is the don't care conditions there. Any doubt in this one? Simplify the expression. Why we are not including this group of mean terms here? So that what we have? So that what is expression now? You can see 0001 what we have. Yes, Sudha has written W bar Z or YZ. Right? So that was 0001, which is common 0. 0 is nothing but the value for W, which is W bar here. Similarly, what we have 0111. 1 is the value for Z. So that what we have W bar Z. That is one term what we have it in a simplified expression. Similarly, what we have the group of mean terms what we have it 3, 7, 11 and 15, which is 1 1. 1 1 is the value for y and z or yz. So that what is the simplified expression we have it? F is equal to w bar z or y z here. I can see that some students writing the expression for this one w bar x bar, right? Right. But at least you understood why we don't have to include a w bar x bar term here because these are zeros. Zero is a don't care condition and d is a don't care condition there, right? And all we know that the mean terms 1 and 3 are already included in the group of this one. That's the reason we ignore these two don't care condition and we consider this as 0 and 0. That's the reason we'll not include the group of mean terms 0, 2 and 3 there. Everyone understood this one? Any doubts? Now we'll go to the next one. We have something called as I want you to take this as an exercise and write this one. It's already 10:45 now, right? I'll give this one, right? That's the reason I can want you to take this as an exercise so that in the next class we can discuss this one. Everyone note down this truth table. A truth table for binary to XS3 BCD code conversion. BCD stands for binary coded decimal, right? Since there are 4 variables, we have 16 input combinations, and you can see from these input combinations what we have it. These input combinations what we have it here. These input combinations what we have. For these input combinations, the output is don't care. These input combinations for 1 1 0 1 0 1 1 0 1 1 0 0, right? All these input combinations, the output is don't care. It means that output is not bothered, right? Does not care for these input combinations. The output is generated only for these input combinations, what you can see from 00 to 1001. When I say x is 3 here, it means that you add 3 to that, the binary number, the BCD number what we have 0000. To this number, if I add 3, what you get now? Take an example. What we have, I don't know where to write it here. We have 0 here, 0, 0 and 0. Now add 3 to this one. What we get? When I add it, what you get here? 1, 1, 0 and 0. This is nothing but your access 3 code here, which is nothing but access 3 code here. To that BCD number, you add 3 to that. When you add 3 to that, you get access 3 number there. So that for 0, if I add 3, you get it as 0, 0, 1, 1. Similarly to the 1, if I add 3, what you get? 1 plus 3 is 4. How do you write it? 0, 1, 0, 0. Right? Similarly, what we have? 0, 0, 1, 0. 2 plus 3 will be 5. How do you write it as 5? 0, 1, 0, 1. Right? This is a access 3 equivalent for the binary numbers. What you have from 0 to 9 there. Again, 3 plus 3 will be 6. 0, 1, 1, 0. Similarly, what we have it here now? 4 plus 3 will be 7. Similarly, what we have? 5 plus 3 will be 8. Right? 9, 10, 11 and 12 here. Right? Since we have what we have, the input combinations what we have for 0 to 9. For this BCD, we have generated the access code here. For rest of the combinations, the output access3 code what we have is don't care terms. It means that the output is not generated for those input combinations, right? Now how many output variables? You can see this one. How many output variables we have? A, B, C and D. And you can see that all the output variables what we have, A, B, C and D, what we have, but all these input combinations are, for all of the output variables, these input combinations are don't care there. So that now if I want to get a simplified expression for this, all the four output variables A, B, C and D, what you write? You need to include the don't care terms for all the output variables A, B, C and D, because for all this input combination, because it is applicable for all the output variables A, B, C and D there. So that how do you write it now? How do you write in decimal equivalent notation? Right? You can see here what we have, A, what we have. This is nothing but if you see in decimal notation, everyone you can put it here. 0, 1, 2, 3, 4, 5, 6, 7, 8. Right? Everyone write that way so that you don't make mistake while writing the decimal values for which the output is 1 and for which combination the output is D. So that what we have 0, 1, 2, 3, 4. What we have 5, 6, 7, 8 and 9. For these input combinations it is 1, and for which combination it is D here, you can see from this one, from 10 to 15 for all the output variables, not only for A, for all the output variables A, B, C and D, it is D there. For these input combinations it is D. Similarly for B, for which combination it is 1, we have 1, 2, 3 and 4, and this is 9. Right? Similarly what we have 0, 3, 4, 6, 7 and 8. 7 and 8 here, not 6. Right? Looking at the truth table, now you know how to come with an decimal equivalent notation and come with that equivalent form here, right? And you can see here the don't care terms what we have is common for all the output variables. It is same for all the output variables A, B, C, and D there, right? We'll wind up in. Now what you need to do is, everyone, since there are four output variables, now you need to come with a simplified expression for all of these output variables A, B, C, and D. So that what you need to do now? Now you need to draw four K-maps, and each K-map is for each of the output variables. One is for A, the other one is for B, the third one is for C output variable, and the fourth one is the D output variable, right? Right? And put the values for which mean terms it is 1 and for which mean terms it is D, right? Once you write it, next what you do now, simplify the k-maps and see whether the D terms will help in creating larger groups or not. If it is helping us in creating larger groups, consider the D as don't care terms as logic 1. If it is not helping us in creating larger group of mean terms, consider the don't care terms as logic 0. And accordingly, identify the prime implicants and essential prime implicants and come with a simplified expression for the output variables A, B, C, and D. Everyone, you can do this one, take this as an exercise, right? So that in the next class, tomorrow also, Tuesday, we have the class at 9:45, right? Everyone, please be log in at 9:45 a.m. sharply. So that because since you have the class at 11 there, we need to start the class exactly at 9:45. If you are late, what will happen? I need to wait for you guys, right? That's the reason, right? Please make sure that you log in and be ready at 9:45 a.m. so that exactly at 9:45 I can start. Everyone do this one. Take this as an exercise. Come with a simplified expression for A, B, C, and D. Right? We'll discuss about this expression, simplified expression in the next class. Thank you, everyone.